Hey guys, welcome to Digital Srini channel on YouTube, and this video is again based upon one of your requests or many of your requests, where I'm very glad that you find my image processing tutorials to be very useful, but you have questions about how to properly read geotiff files and especially how to extract individual bands so you can actually process them. Once you extract these bands, once you read these images into Python, then any of my videos on image processing hopefully can be applied, for example, image segmentation or extracting texture and so on. Now, I'm going to use a library called rasterio. Many of these are a bit tricky to install, but rasterio seems to be a little bit more straightforward. So I'll go through the process of at least how to install rasterio and then read an image, extract a couple of bands, let's say red and near infrared, and do some basic math to calculate our vegetation index. I'll also talk about, okay, when you do this math, sometimes you get divided by 0, how to quickly handle that. So this is just the summary of what we're trying to cover. Okay, so let's jump into the code first and then go through these one by one. Okay, so here we have the code. Again, I'm going to share this on my GitHub page, so please pay attention to this video and don't worry about writing down these links. And first of all, how do you install rasterio? Well, it depends on actually another library called GDAL. Okay, and to install this, I'm including these two links, and you just need to, again, if you just do pip install rasterio, it will not work on Windows. Okay, I tried that, it will not work because it says it needs this, and if you do that, it asks you for something else and something else. So the best way, the easiest way, is just follow these links, okay, and you'll get to this page. For example, let me zoom in so you guys can see this a bit better. Okay, so this, what I'm trying to show here, it tries to restart now. Okay, this is fan. Let's look for our GDAL. You have to install GDAL first. Okay, so go ahead and find that. I shouldn't have zoomed in, but we'll find that in a second. Okay, so once you find this, go ahead and find the right version. For example, in my case, I'm working with Python 3.7. Okay, so I'm working with Python 3.7. So I'll go to this page and I'll find 3.7, which is CP37, and I'm using this 64-bit. Okay, so this is the file I'll download. Okay, the wheel file, and wherever you download, just in the downloads is okay, and do exactly the same even for the other one. Okay, even for your rasterio. Okay, God, let me quickly get to our rasterio. I shouldn't have resized this, but this is going to take forever. Okay, let's go there. Let's come down to rasterio. There you go. Sorry about that. So same thing with rasterio. Okay, if you are working on Python 3.7, go ahead and download this 37, wherever it says CP37. It's up to you whether you want to do 64-bit or 32-bit. It depends on your operating system. I'm using 64-bit. Again, if you're working on Python 2.7, this is the file you would like to download. Okay, so once you get this idea, so these two, then it's pretty much simple. Then you just navigate. Right now, I'm in a directory called geotiff. But wherever you download that, just go there and then just do pip install that file name, starting with GDAL. Okay, and once that gets installed, go ahead and do rasterio. That's it. Okay, so this is how you get your system ready for rasterio, and this worked for me on 2 different systems, so no complaints there. Once you install it, okay, the next issue I faced is I do not have any of these geotiff images. I know you have to sign up somewhere online and you can download and all that stuff. So I'll let you guys figure out how to download those images from many sources, government sources where you have these satellite images. But one place where I found, where I can download these images is, I'll leave this link, in the description, but these are the files I just downloaded. Now, these files actually here, each band is saved as a separate TIFF image. So when you open this, it's only one band. So B4 in this example is red and B5 is near infrared. So I'm going to use this later on, but I did a quick Google search and downloaded another file that actually has multiband. Okay, all that back information, it took 5 minutes, but it's worth it. Now let's get into raster IO part. Okay, so you import raster IO, and then if you would really like to use raster IO plotting, you can go ahead and import the plot or show. Okay, if you just want to show the plots, it can be very helpful if you just use raster IO. I'll talk about that briefly. I like to work with matplotlib, pyplot, or even Seaborn, but this is fine. So let me go ahead and import matplotlib. Now to read a file, to read a geotiff file, because we are importing raster IO library, so it's just rasterio.open. Okay, so let's go ahead and do that. Rasterio.open, and this is my image name, my geotiff file name. Okay, and it's under a directory called images. So let's go ahead and do that. And this is not opening image as a Numpy array. Normally, when you open a TIFF file or a JPEG file or something, when you do scikit-image or OpenCV to read this, it's immediately a Numpy array. But this is almost like an object. In fact, this is an object. Now, how do you plot an object? That's where raster IO plot can be very useful. If I just do plt.plot, it's not going to work, because this is not a Numpy array. This is an object. You can see that up here. So when I do show image, it should actually, if I go to plots, it should actually show this image, because obviously this understands how to display, extract the right numbers from this object and then display it. Let's do something now. Instead of doing that, as soon as you open your image, right, the image is open. Now I'm going to read that image and assign it to something called a variable called full image. Okay, so when I do this, immediately up here, this is very important. You see that the image is 1188 by 1912 pixels. And the 3 in the beginning stands for 3 bands that it actually has. Okay, and if it has 10 bands, this image, you'll see a value of 10 right there. And hopefully the metadata contains what each band information is. Unfortunately, geotiff, many of the images, at least a few images I opened, the metadata is absolute crap. I don't know how you guys live with this type of metadata. Then you have to, sometimes it makes it unusable, the image, right? Same with this image. Let's look at metadata, because I was trying to figure out which band corresponds to red and near infrared. It's not clear from this. Again, we'll see how to extract this information. Sorry for complaining. I try not to complain much, because this is a free image I downloaded from somewhere, so it doesn't make sense for me to complain. So let's move on. So how do you find out number of bands? Obviously, I just mentioned that, okay, the first 3 that stands here is the number of bands. But if you just look at original image and not assign or not read it, the original image.count actually gives you the number of bands. So let's go ahead and run those 2 lines, and you see the number of bands in the image is 3, right? So you can just because img is an object, you can just get different things out of it. Okay, so img.count gives you number of bands. Now, just like we did img.read and assigned it to full image, if you want to assign individual bands to different images, you can just say image band 1 is img.read 1 and 2 and 3. Now, unlike regular Python where things start at 0, 1, 2, 3, here bands actually start at 1. So 1 is basically the first band. Obviously, I copied, pasted, didn't change it here. 2 stands for second band. 2 stands for second band, and 3 stands for the third band. That's it. Okay. So this is how you assign it to individual bands. And now each band is just a 2D image, 2D Numpy array. So I can plot it. That's exactly what we are doing here. Just go ahead and PLT using pyplot, using matplotlib. Okay, so now let's go ahead and see how these 3 different bands look like. So here it is. Based on this image, I can kind of say either this first or the third image are red, and this is probably near infrared based on how it looks. I may be wrong, but again, I'm not an expert in this field. Okay, so in fact, later on, let's just use this as red and use this as near infrared to do some math for our vegetation index. Okay. Now, what else can you do? When you do, again, my IMG is an object. Okay, these are all individual NumPy arrays. So your object.crs gives you the coordinate reference system. So let's go ahead and plot it. Let me move this up. Let's go ahead and plot print img.crs, coordinate reference system. So it's basically saying this is the coordinate reference system, cron D211, and units are meters, and this is the authority, what is the axis, and all of that information. So there is some metadata. I'm not saying there isn't much of metadata, but I was looking for something and I couldn't find it. Now, if there are any description, like usually for these images, you can actually add descriptions. And here, I think there is no description for this raster. Okay. What else can you get from this object? One other thing is to find out the geotransform, any transformation. So right there, so there is your geotransform numbers, and of course finally I would like to plot the histogram of each band to see what type of information it contains, right? Sometimes you get the same information. In this case, if you look at band 1 and band 3, mostly same, slightly different, right? So let's go ahead and plot it. All I'm trying to do is rasterio.plot. Okay, remember now I'm using the plot and then the histogram function within that rasterio.plot, and then I'm just using my full image. Remember, the full image is basically all 3 bands, so that's what I'm trying to use here with number of bins 50 and so on. So when we do this, you can see, well, looks like something is happening down here, but I have a huge peak at 255. Why is that? Well, that's definitely because when I go back to original image, all of these regions outside of this vegetation or whatever that, the actual image, all of these regions outside, they do not have any data. Well, they're white, assigned a pixel value of 255. So that's overwhelming our histogram values here. So I see a big peak in 255. Even when you do some sort of a math, that becomes an issue where you don't have pixels. So let's kind of zoom in. Let's actually zoom in a little bit. How do we do that? Well, it's a NumPy array. Watch my video on NumPy array. You can do slicing, you can do all the kinds of stuff. So here, what I'm doing is clipping the image, which is basically my clipped image is my full image with all the bands. When I put this, again, in case you don't know NumPy, I hope you do. So I'm just looking at full image. I'm taking all the 3 bands, but instead of taking all 1188 pixels and 1912 pixels, I'm just going from 300 to 900 and 300 to 900. So within this image, if you just go to 300 to 900, so I'm hoping I would be somewhere in the block middle right here. Well, let's plot and see. Okay, so my subset of the entire image is that. And now let's go ahead and show the 0th band of this image. So when we do that, we are inside now. Okay, we are inside at this, we are inside in this region, as you can see from this region. Okay, so there you go. Now, why is it showing up in red? That's because when I am actually plotting it, ImShow, it uses the default color map. You can assign a different color map if you want, but I'm using default color map. Anyway, let's go ahead and look at the histogram for the cropped one. Now we should hopefully see something happening. I still have some 255 pixels. I still have some pixels with value 0, showing the black or completely dark regions. But in between, there seems to be something happening. My band 1 is in this color, and band 2 and band 3 is all the way down here. So between band 1 and band 2, there is some overlap, slight separation, and band 3 seems to be right around here. Anyway, this is just a qualitative way of looking at your pixel values and trying to infer something about these images. Now let's actually do something that is useful, which is look at NDVI, or normalized difference vegetation index values. And the way you do that is you take your near infrared pixel value and subtract red pixel value from that and divide the whole thing by near infrared plus red. Okay, so this is your NDVI, and this is simple math, and we should be able to easily do that by first extracting the red and NIR, right? How do you do that? My red is basically my clipped image. Let's work with clipped image, not the full image. So basically we are working with this image, and let's extract the red. By the way, our clipped image also has 3 bands. Okay, we are not clipping the bands. Now is the time to extract it. So let's go ahead and extract the 0th band, which I am assuming is red. And let's assume, well, I don't know, let's just say 1 is red and 2 is near infrared, right? So that's what we said when we looked at this image. 1 is red and 2 is near infrared. It kind of looks like it, that's why I'm assigning. Again, the metadata did not have that information. Okay, so now I'm assigning a new variable called new clipped, and my clipped image with my first band represented by in NumPy array, you start with 0, so that's what we're doing. And I'm converting that. If you look at your clipped image, you see it says unsigned integer 8. Yeah, array of unsigned integer 8. That means the values go from 0 to 255. Now, when you do math with these, then the output is also going to be an integer, which means there will be a lot of rounding errors. To get away with that, to overcome that, let's convert our values into floating point. Okay, so we can work with decimals. That's exactly what I'm doing. I'm extracting the first channel or 0th channel in NumPy array and converting the whole thing into a floating point number. Same thing with the near infrared. Again, we assumed that the second channel, or in NumPy it would be value 1 as near infrared, so let's go ahead and get that. Now NDVI is basically like we said, NIR minus red, right? Near infrared minus red divided by near infrared plus red. So when we do that, something happens. You see there is a warning here that says runtime warning, invalid value encountered in blah blah blah. What it basically saying is, hey, you're trying to divide something with a value of 0, and that's, I don't know what to do with it. In fact, if you look at NDVI clipped, there is right there, NDVI clipped, and some of these values are NaN. Like if I open this, let's do this, this is important. You see all of these values are floating point, right? And somewhere in here you'll find something, it's either says infinity or NaN, one of these two. I forgot, I think it shows NaN here. Let's keep going. Okay, oh, I thought I saw something. Fine. Okay, there you go. NaN. Okay. At this pixel, there is probably no information. There's probably no signal at all, which is very common in geotiff files, right? At some pixels, there is you don't have any information. So when you divide something with 0, it's going to say it's NaN or sometimes INF. So NaN in this case. So the way to handle this is, let's use NumPy, for example. I think I could have used this because I thought maybe it doesn't give an output, but let's do this in a slightly different way. Let's use NumPy to do the math. And in NumPy, there is something called np.divide, np.add, and so on. So I'm going to use np.divide. Divide what? First, do subtraction, np.subtract, the clipped minus and the red one, right? And then np.add this. And I'm going to divide this by this. That's exactly what this function does. If not, just use this. It doesn't make any difference. So let's go ahead and run this line. Now, again, I get the same warning, right? I mean, why I should get the same warning and exactly the same type of output. If you look at these two, exactly the same output. So I probably don't even need this step, but I'm just showing you how to do it using NumPy. Now, you can, what I'm trying to do here is, there is a function within NumPy called NaN to number, which means you can actually replace NaN with a value that you provide. This is great. And I believe NDVI, based on the formula, I can basically say it goes from -1 to 1. Okay, -1 to 1. So let's go ahead and take all NaN numbers, NaN values, and replace those with -1. You can replace them with anything. I'm just replacing them with -1. Okay, you can do -100, but when you plot it, it looks weird because you're changing the range. Okay, that's why I put it to -1. So let's go ahead and do that. And now when I open NDVI clipped, there should be at least, I thought I saw something, there should be some -1s. You see some of these -1s, this is where we used to have NaN. Now they are changed to -1. So at least now these are all numbers, so we can do something else with this. If I want to go ahead and take this image and do some more image processing, now I can do it. Okay, so let's look at it. How does it look? So let's go ahead and plot it, and there you go. That's your NDVI plotted. Okay, you can also include color bar if you want, so you can figure out. Sorry, I didn't include that earlier. I always include that so you can see, okay, so this is minus 1 and that is 1 up here. So there seems to be a lot of vegetation around these regions. That's my that's my inference by looking at this. Okay, so I think that's good, but sometimes these bands are not in a single image. Like usually geotiffs, you have multi-band images, but then for example, if I go back to my page here, these are all individual bands. So these can be a bit easy to work with, right? Now you have individual bands. So B4 is red and B5 is near infrared in this case. So I already downloaded them and I renamed them as red band and NIR band. And all I'm trying to do here is open that image. Okay, let's do that, which creates an object. And then see look at a smaller subset of this image. Resize this image, because if you look at my red, I'm not sure if it shows the size here. It's a humongous image. It's a pretty large image. So I'm reshaping it into half of its size. Now we can find out what that size is. Red image is, even after cutting the size by half, it's 4K by 4K image. So the original image was 8K by 8K. Nothing wrong. You can still work with it, and rasterio gives you a way of actually loading like individual chunks, or you can use Numpy to load an individual chunk of it and then work on it, or divide this large image into individual patches. Okay, and then work on each patch, just like I showed in many of my videos, you know, working with multiple images. Now, getting back to this, so here we are resizing it, and now you can actually have a quick look of what we have. So let's go ahead and plot it, and here is the image. Okay, this is the red band right here. Now let's take only a subset here again, because we don't have much of information over there. Again, you can still work with the whole thing, because we are replacing these values with -1 anyway later on if you want. So let's go ahead and that's the subset. That's the smaller image I want to work with. Okay, now I'll do exactly the same with my near infrared. I'm reading this separate image, and then so in summary, instead of reading one image with multiple bands and separating each band and assigning it to red and near infrared, I'm just reading multiple images. That's the only difference. Okay, and there you go. So that's the information we get from here, and the rest of this is pretty much the same, right? I mean, we convert images, I mean these numbers, 8-bit numbers, into floating point, and then we do the math right there and go ahead and show it. Well, in this case, I do not have any pixels with NANs. If I have those, then I would have actually added this line down here. In fact, it does make sense to add that line no matter what, just to make sure you're taking care of it. Okay, so NDVI image, did I already plot it? Yeah, I think I did. So there you go. So this is the NDVI image for this other image, where we know for sure what was red band and what was near infrared band. So once you have this, now you can do any type. I mean, coming from an image processing background, the first thing I would do is look at this image and say, okay, so how can I segment these areas with low vegetation versus the high vegetation? Now you can go ahead and use you know, the texture-based methods or traditional machine learning using random forest or XGBoost, or go to deep learning if you have enough of this data. Okay, so now you know how to load an image, and first of all, how to install rasterio, how to load an image, and how to do some basic math with this. And in the next tutorial, let's cover a different topic. But until then, again, please asking these questions, and if I have some knowledge in that area, I'll definitely try to create a video on this topic if I know how to do it. And please subscribe to my channel. Thank you.